Says the stream is live.
Yeah, and it also has check marks now, like next to LinkedIn and
Ah,
YouTube.
I don't know why it is on LinkedIn, but we'll find it.
No, this is the problem. It says live today at 2 p.m.
Oh,
Yes, maybe if I can change it. Yeah, defaulted.
that's what happened.
So I'm going to change that quick to 12.
Right. I hope it doesn't end the stream. So I did get. Right, I got your stuff. Oh, but it's not going live on LinkedIn. Unless it wants us to do another link.
Yeah, I'm seeing if I can get it to.
Change.
Yeah. Okay, I've got two names. It says check the date and time. I don't think it lets you start.
Once it's unless we do 12:15.
It only lets you choose 12:30, but it still says
If you choose 12:30, you could start before.
12:30 a.m.
Oh, PM.
Yep. Okay, it seemed to like that better.
Okay, good.
All right, there's you and Hamza.
Because the other option is we send out the YouTube link as well.
Right.
All right, so I saw that it changed to 12:30 on the LinkedIn page,
Yeah.
but it's
Okay.
still
So it's probably just going to want to wait for that to start. And I can't hit end stream again.
no, you can't. But what I can do though is like in the meantime, I could send out the invite to everybody with
Yeah, let's do
the
that.
link.
Yep.
Yeah. So just to make sure that people find it.
Yeah, and since I had something scheduled for 1 o'clock, well, I'm just going to make it short and sweet
Okay.
today, um, and we'll choose to end at 1. But go ahead and get those
Yep.
lined up.
So I'm gonna say in the next 15 minutes. So this can go out. And I'll probably just edit the invites as well. I'll put the invite for 12:30. And all right, so I think I got that one out. And maybe we'll have some people join us and all of it.
But like always, it's a recording, so
Yeah,
we'll
so
have
you
that.
get that part. You actually have that part going. So
Yep.
I'll just change this to 12:30. I may have to put these these notifications on mute because I'm gonna get a bunch of them now, which is always good. Always good. And I'll just do a quick post in the group just to make sure that people have the rights.
Okay.
Here's the new link.
Well, I still only see we're 2 hours away. I don't see your updated post.
Oh, because I think what I saw on your thing, it says live today at 12:30. So
Yeah, it actually does. It does, but if people are
hopefully that
making
part
changes,
works.
updated link. Actually, I just looked in YouTube and it's running.
Uh-huh. Oh yeah, yeah, it is running on YouTube. YouTube is
Okay.
running fully. It's just
No, it's running
LinkedIn.
on LinkedIn as well
Oh, it is?
in the original posting. Yeah. It says event ended at the bottom, but I'm watching
Uh-huh.
it live on LinkedIn.
Oh.
So that might affect. So I think if anybody came here to look for us, they're. Wait, what just happened? It just froze. There's only no. I was seeing the original one. It's
Ah,
37
okay.
seconds long.
Yeah, 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 yeah. Hopefully it starts at 12:30. Hopefully.
Yeah.
Because I put that one out just to make sure. Right. And I think all of the other updates are now like coming in. Oh, I think we are live because I just got a note from Mike Ramsey.
What did he say?
He says we're live.
Well, I think when you look at it, every time you pull that last one up,
Uh-huh.
it starts. It has captions and everything, and it says
Right.
previously live.
Right. Yes.
He might be seeing that.
I know the YouTube is like that one is running, but LinkedIn, I don't know.
Well, the new one that says 12:30, we've already
Would
got 6 people
yeah.
signed up for it or whatever.
Okay, yeah. So they got the updates. Great,
Yeah.
perfect. Yeah. That's good. That's good. At least we have that going on.
Yep. And the link to this one today 12:30.
Mm-hmm.
Oh, you said hi everyone. Here's the new link. Okay, great.
Yes.
And I'm going to put that in my comments of the old link. There, so that's in there as a comment.
Okay, good. Okay, so I think we are live though on LinkedIn.
Yeah. No, are you sure about that? Because my I just
Yeah.
looked at it and it's stationary. Right at the
Um,
bottom, it says live today, 12:30 p.m. And then in green, it has Wednesday, August 14th at 12:30.
yeah,
Yeah.
there's another post with it. It says first attempt didn't open, trying again.
Hmm.
So that one is actually live because I think Mike Ramsey told me that we are live on it. So I'm seeing it live and it says 9 minutes ago. So maybe I need to post this link instead.
Wow.
I don't know where this link came from though. I do not know where this one came from.
What that Mike posted?
I'm gonna send it to you on
Yeah, I see it
LinkedIn.
now. I see it on Mike's message.
Okay, good. So I guess we could start.
Okay. We haven't thoroughly confused everyone by this
I
point.
know, it's too many links. Too many links.
Yeah. Well, go ahead and get us kicked off while I get my show
Yep,
and tell together here.
good, perfect. So if you all can find us today with one of our many links, because it is August, and I think maybe our computers are still in summer mode and they're doing whatever they feel like doing today. So we've been bouncing around with a couple of links, and hopefully this one finds its way to you. We will be sending updated links with the recording at the end of the session. But for those of you all who did join us and found us, thank you so much for finding us. We really appreciate you looking for us. Today we're going to talk about grease sampling, and Rich is going to give us a quick demo of it because I know this part is like very important if you're actually physically doing the samples, and that's the part that you want to make sure that you actually get the real thing, not contaminated, actually representative. So Rich is going to give us some more information on that, and I'm going to pass it to Rich to sort us out with that. So for those of you that are here, thank you.
Yeah, and while thank you, Sonia, and now that we have a new session here, I have
New
to upload my
session.
presentation again because it was on the old one. But hey, we're getting it figured out, right?
We will get there. We will get there eventually. But you
Yeah,
know what? We'll have some fun while we get there.
that's right. Yeah, the bottom line
Definitely.
is, can we show? Let me see one
Can we
thing.
share it? Is it working to share?
Well, yeah, I think let's do this. Yep, that I can add to the stage. And then I do have a video I want to show. I got to think for a
Ah.
moment. Let me just take, I realize now where that one is. Let me go grab that
Mm-hmm.
quick, and then we'll be good to go.
Good.
That's that one. Okay, there's the sneak preview. Okay,
All
let's start
right.
here. And thank you everyone for finding us, tracking us down, and getting in here. But I want to talk about. I just want to update us today on a few things around grease sampling methods, kind of the latest and the greatest. And some of our previous discussions, we've talked about the established methods that are out there for sampling, and it's all around this basic kind of fundamental thing that we developed, the grease thief. And you can see a picture of two different iterations of the grease thief here. You've got the kind of standard one with the piston and the cap here and the handle, and then you have the second one that's shown there that has a stinger probe on it. And we've talked about where you would use those, and even sometimes putting them in a T handle like you see at the bottom there to be able to core a sample. We've also talked a little bit about the Grease Thief Slim for small openings, works nicely on wind turbine blade bearings, and anywhere where the access is limited to a smaller diameter, because this development drops that opening size from a half inch, requiring a half inch clearance, down to 0.28 or about 7 millimeters. So now we get into very small openings, not into the grease supply, right? Because that's only going to give us the new grease that hasn't been there yet. But any openings, drain holes, plugs that we might be able to access. Now we get down into that smaller requirement. Now I've got, first thing I want to talk about, which is the pickpocket. And the
Mm-hmm.
pickpocket at first glance looks a lot like the Grease Thief Slim that we just showed. However, it has the same small diameter, but it automatically separates a section for transfer to a testing vial. And so that makes it that much easier to core the sample and then transfer a small piece. Previously, we had that where you were taking the Grease Thief Slim and then you were opening a Grease Thief, and then you would transfer the there we go. You would transfer from the Grease Thief Slim into a Grease Thief. But what we've found is sometimes people want just some really basic analysis. They don't want to necessarily go with the full 10 different tests that you can get with a 1 gram of grease in a Grease Thief. They just want to screen that sample. They just want to look at, is there wear levels here? Has the color changed significantly? Some real basic screening tests. And when you do that, you end up with this long tube, and it's kind of hard to handle. So now we have that tube cut down to size, if you will, and this might be the kit that we would use that for. And I'm going to show this to you in a minute. But basically, you can see in this drawing that you've got a separated section here. So your tube and your piston that is originally on the tool gets ejected into the tube with the grease sample that you've taken. And now you have that slightly more than 1 gram sample completely filling that tube and ready to transfer that or put that in a vial and then immediately start doing analysis with that. So the background is, here's all these different kits, right? Pillow block bearings, electric motors, the MOV gearboxes, the robots, and then of course wind, which is one of our big applications. And then it kind of shows you what all these kits look like, including the Grease Thief Slim. But the newest development, the Grease Thief Pickpocket, or the GT Pickpocket, does 2 key things. We identified some gaps in what the Grease Thief Slim left us with, and namely, you don't always want to transfer it to a grease thief, and if you don't, you may be stuck. Some of our customers were using scissors to like cut the tube off, and it would be various lengths, and was the full of grease or not full of grease. I couldn't even get the cap on the vial in some cases. So now we've automated that process in the sampling process, so that tube section is about 2 inches long, and it's the same every time, and it just comes right off into the vial, and the vial then can be for transporting it. It can be the actual vessel that gets tested in the lab, or even on site. We talked about the mini labs, and if you use that FurrowQ device, you just drop that vial right in. You know what the volume of the grease is. You get a ppm out, and you've done that screening process that we talk about. So really, it gets us into an accurate, precise sampling per D7718. But previously, you had all this plastic that kind of went to waste, and we've reduced that substantially. It's like 80% reduction in the single-use plastics for the sampling process, if what you're going to do is that screening process. So that's a big enhancement and improvement there.
It is.
We found some folks were still not wanting to go into all of that. Maybe they have an established method for sampling, and they just have this small amount of grease, and they don't want to go to the whole tool and everything else. So we came up with another way to do this, and we're calling this the Grease Thief Filler. And you may have seen some postings on this. I had these pink things sitting there. Well, we don't make them just in pink. We make them in all kinds of colors now. All colors of the rainbow there. And
I had a preference for the pink, but it's okay.
That's all right. But so let's see. Let me see if I can swap it out and do a demonstration here. If I pull this back a second.
Yes.
Yeah, and you can kind of see here these fillers. And what I want to do is show you kind of what you would get in a kit for using that. So you get something mailed out to you, and in that you're going to have these fillers. Now, I've got some plain white ones here. We have our college football team is Penn State, and they call those the generic blue and white uniform. Their name is nothing. So it's kind of like the version of that. You can see here's 10 of these. You've also got the 10 vials to put the sample in. And then you have these pre-staged fillable tubes that are from the grease, from the pickpocket. So these are pickpocket tubes. And you can see that black, that's a piston. Each one has its own piston. And what folks have found is, as we've come up with some techniques to take grease samples, people want to say, well, can I just do this? Let me try something over here. What is very difficult because of physics is to take a tube, a vial, whatever, and fill it with grease. It sounds like a simple task. And certainly it's easy for oil, right? We just pour some oil into a vial, the air is displaced. But when you start to push grease down into a dead end tube, air pockets get in the way, the grease is sticking to the side of it. you get these large air pockets. And when you're measuring quantitatively the wear that's present, or anything else that you might want to measure, if it's not uniform, if you've got air
Mm.
pockets, it's going to throw those numbers off. And
Yeah.
there's the chance that you have a significant wear problem, and you go and measurement and it underreports that value, and you
Hmm.
think everything's okay. You miss the opportunity. And in all of this, in sampling, we want to be accurate and representative. And that's what you find in D7718, the standard for taking grease samples. So we've got some pretty elaborate tools, but now we've made it fairly simple, where you've got this setup where you've got, again, 10 of each, right? So
Right.
kit allows you to get 10 different samples. And so from this Ziploc, I take that clean tube, and it's kind of hard to see, but there's a flat end piston right in there.
Hmm.
So now what I'm going to do is open this case, and notice it's clean, it's sealed, and I tear that open, brand new. I don't have to worry about it being cross-contaminated or
Hmm.
anything like that. I zip it back up, and what I can do now is take that and put it right in place.
Ah, that's
So
it.
now what I've done is I've created a tool where I can remove this plunger section from the
Hmm.
opening. Okay, so there's the pickpocket tube with the piston right there, and you can see it's got an open area waiting to accept the grease. And
Mm.
here's the pusher section, or the filler
Yes.
section. So I'm going to start with this, and I'm going to take maybe my spatula that I've
Hmm.
taken the grease off of the machine, and I'm just going to pack it in there. And I can just put it right in, and I just rotate this around until I fill that cup so that there's a little detent to take the piston. So I don't fill it
Right.
flush to the top, but kind of it naturally happens when you're trying to
Hmm.
roll grease off. You'll make this little
Yes,
cone of
always.
grease in there, right? And over time, you'll find exactly how much you need to fill this up and so forth. But now that the grease is in there, what I do is I take this section and bring them together, makes a seal, and then
Hmm.
I'm going to push down on that. When I do,
Right.
and I don't have messy grease for you here today on the video, but you can imagine as I push this down, and it'll go
Hmm.
all the way down, that'll push the piston to the far end. And what I'll end up with at that point is that piston gets pushed to the far end is this.
Yeah, sample.
This is my sample with a piston sitting right there. And that's where I'm going to take the vials, and I open that up. Again, everything is sealed and kept
Yep.
clean, so you don't have to worry about cross contamination, dirt, dust. In other words,
Yeah.
whatever you analyze or send to a lab to be analyzed is going to be exactly what you get. So now this is full of grease in our world here, and we drop that into the vial, and we put the cap on. And
Right.
it's going to sit at the same spot each time because
Mm.
these are made for that
Right.
height, and they're made uniformly. We could also look at it, and let's say we came up short on grease. We can use the height of the piston as an
Ah.
estimate of the volume. So we can do,
Mhm.
even if we came up short and didn't get a full amount of grease, maybe it's a little less than a gram, but we still want to measure it. The height of the piston will tell us what the
Good.
percentage is. And then I can do an offset calculation for my parts per million values or what have you.
Ah.
So this is what you end up with. Very simple. And a
Mhm.
lot of folks, they want to start out in grease analysis. Just tell me if there's wear in this
Yeah.
situation. And they can do that really quick. The other thing that's nice is you send this to you, maybe you screen it yourself with your mini lab. Notice everything is, if I come back here, it's clear inside. So we can do the colorimetric analysis that we've
Ah.
talked about right here as well, and
Yes.
compare that to the new grease and see if there's been a significant change. So once I have that, it's like, well, what do I do now? I just pitch it? No, I hold on to this because you haven't wasted any grease. You still have
Mhm.
100% of your sample after you do that screening process. So what we could do next is open this back up and take that back out again. Now I've got my grease here, right? Let's say, hey, there was a lot of wear. and I'm a little concerned about that, and I want to send it off to the lab for analysis, which means I have to get into a grease thief, right? To take
Yes.
a sample. So watch this. I take the cap off of that, then this slips right inside.
Ah.
Okay. So now they're connected. And I'll just pull this piston back. You can see it's actually pulling that in there a little bit. But now all I have to do is take a little pusher rod, and I'm going to push that piston right in to the end. And now that grease has been transferred into the grease sieve. So now
Ah.
you can do the full analysis. So what we've come up with then is a way of low cost, low plastic
Mm-hmm.
waste, fairly easy to take a sample, even can be attached to the pickpocket tool
Yes.
itself, get accurate targeted samples. And now we have a way using the GT filler to transfer that directly into here, low cost sampling, and then transfer it to the grease thief if we need to do that advanced 10 tests per ASTM 7918. So
Mm-hmm.
lot of options there, and I think what this does for us is it really kind of changes the game
It
about
does.
what does it take to get started on all of this, right?
Mm-hmm.
How much does it cost? What kind of answers can I get? So when we started, we're like, we gotta be able to do everything, right?
Yeah.
We got to have the perfect sampling tool, and that's what the grease thief is, right? Perfect sampling tool, and then we need tests to cover every possible parameter that someone
Mm-hmm.
might want to measure about grease, wear, consistency, contamination, oxidation, and we can do it all. And that's what D7918 is. All 10 tests,
Mm-hmm.
maybe even 11 or 12 if you get creative, with 1 gram of grease. But then over time, you start to realize that people are still taking the baby steps.
Yes.
They're just trying to figure out, is there something wrong with that machine? Can
Mm-hmm.
I learn anything from the grease? And can I do so very cost effectively? So we've got the cost effective solution. We've reduced the amount of plastic waste
Plastics.
that's in
Mm-hmm.
that process, but it doesn't end there because it's then transferable, quantitatively transferable to the grease thief. So you can take those. And I'll tell you, Sonia, our experience is that it's somewhere between about 7-8% to 15% of grease samples are the ones that we really have to focus on,
Ah.
right?
Okay.
Think about it on the oil analysis world. I guess
Yeah.
the thing is, 90% of your samples are like, that looks fine, sample it
Yeah.
again.
Mm-hmm. Yep.
And you just want to focus on those 10%. And
Yep.
it's kind of like that with grease too. Now, I've had some examples where um, machines have been really neglected, and
Yes.
it needs to be a lot more than 10%.
Oh yeah.
So you might have 20 or 30%. But the idea here is that let me screen out these samples. Let me
Mm-hmm.
have a low cost way of getting in there and grabbing a sample and then screening that to see, is it probably a problem or is it
Yes.
probably not? Take that smaller percentage and then move on and do that advanced analysis. And so we try to listen to what customers are saying, where their challenges are, what they need to get
Right.
a little bit stronger and better in that. And this is our way of kind of responding to that.
Yeah, and
So
I think that helps a lot because most of the times, like you mentioned, people may not know where to start. So just by getting the basics done, understanding what they want to find out about degrees, and then having the ability to transfer degrees to say, okay, well, I want to test more, I want to do some more information on it. I think that breaks it down to a whole other level because some people get shy when they talk about grease analysis. Yeah,
yeah,
they
and
do.
I'll also say this, that probably what's holding the record now for most grease samples being analyzed is in the
Mhm.
rail industry. That's what I'm seeing now,
Ah, that's
and it
interesting
is,
though.
yeah. And anybody who's run an oil analysis lab and looked at that they know that the rail industry is looking for a very low starting cost to
Yes.
figure things out. And so we were kind of doing a modified version of what you see here, but it was all kind of
Mm,
after the fact. There was a tube, and the tube had to be cut, and then it was
yes.
put into a thing. And then if they wanted to do more analysis, it was very tricky to then get that
Ah.
transferred over into a
Mm-hmm.
form to do it. So we've really addressed all those steps now. So anybody that's either, hey, I just got to convince some people that
Mm-hmm.
this is a worthwhile technology, that I can learn good things, don't have a lot of money, and
Yeah.
and we're kind of trapped by the success of oil analysis and the
Yes.
expectations of what all that automation is on the
Mm-hmm.
oil analysis side. But it's harder with grease. It's harder. It's not
Mm-hmm.
this easily pumped liquid.
Yep.
It's not a simple sample bottle that that you can basically give away for
Yeah.
free almost. It's more complex to have a good sampling methodology. But I think we've done both. We've found that
Mm-hmm.
trade-off to have a low cost, starting point for this,
Yes.
without giving up any of the accuracy and representativeness of the analysis that you're getting.
Yeah, and that having it, like, I absolutely love that concept of having it in that clear plastic bottle and not even touching it before you get to the idea of, okay, this is what we need to do. Because a lot of people get stuck at that point. Like, I just want to know what's going on, but I don't know what to do, you know? So having the tools and the techniques involved for that, that just, you've bridged a lot of gaps there, for sure.
Yeah, yeah, I think so, and it'll be interesting to get some feedback from folks and hear what they, would like
Yeah.
to see or what they need to see with that. So this is it. We're definitely reducing waste here
Oh,
with the
for
with the
sure.
GT filler. We're going to be soon. So we've been 3D printing. What you saw here today was 3D printed,
Ah,
and that's
nice.
why you see all those colors and everything. You're
Yes.
pretty flexible there, but we're going to work to drive the price down by creating some injection molded solutions here.
Mm.
It'll improve the cost, but it'll also improve the smoothness of fit of these
Ah,
parts and make it easier to transfer the grease over, which will be great. But you
yeah.
can see at the bottom, the sleeve there, you can see what that kit's going to look like. And what you're ending up doing is you are trading in, and if I could show you here side by side, you're trading in this much plastic for this much.
Oh, wow.
Yeah,
That's a big difference.
it's a
That's
big
huge.
it's a big difference, and it's something that you know uh, we want the machines to run, but most companies are really getting more concerned about their
Hmm.
environmental impact and so forth. So it's another kind of development there that can really not lose anything in performance and capability, but also say, hey, we're reducing waste in the process. So
Yes.
that's a good part to that. Yeah. So I know that we're trying to reach the folks in the Middle East with this, with the
Yep.
Kingdom of Saudi Arabia and their neighbors. And so one of the things I wanted to point out, there's a number of labs around the world that are using the Grease Thief and have these tools. The first lab to test the GT filler was actually Ecol Labs in Poland.
Ah.
And so, being in Europe, they're in kind of the same time zone area over
Hmm.
there. And the folks from Ecol were just at one of the recent um, conferences that was
Yep.
held in Saudi Arabia. So they're reaching out and they're meeting those folks. They're not the only lab, but they're certainly one that is can be worth a look for people from that side, that part of the world. We've got the folks at SGS, Bureau
Hmm.
Veritas, Polaris Labs,
Hmm.
ExxonMobil has the grease thief technology,
Yep.
and Running Land Labs over in Shanghai. But
Hmm.
with this being delivered and focused on the folks in the Middle East, certainly someone in their time zone and someone that has had a presence there could be helpful. So that's what we want to do. We want to find the critical applications, the high risk components,
Yeah.
and start there, and then look at the sampling kit options. Consider some of what we shared here today, and then if there's special applications that we don't have an existing solution for, we love that. We love diving into that, and let's talk about it. Let's look at some pictures. Let's look at some
Hmm.
drawings, and let's use the fundamental principles of the theory of sampling
Hmm.
and the ASTM standard 7718 and come up with a good solution for it. So we've just added a number of options to that. I think people are probably running out of excuses to not sample grease at
Yes.
this point.
And they should. They definitely should. They should be sampling at this point because, like, just, understanding the basics and knowing what's going on with your equipment, I think nothing could compare to that. Like we can't wait until these things fail, because when they fail like that, it costs a lot and
Yeah.
it's not pretty. So we don't want to do that.
No, and something you and I have talked about before is that when we have a focused study in one
Hmm.
in any area, it seems like taking the existing practice and
Yep.
working towards grease optimization, right? Not
Hmm.
only the failure, can I catch the failure before it fails, but what about grease optimization? We
Yes.
are finding that most of the time, about twice as much grease that is
It's
required
the.
is being used and wasted.
Hmm.
So that's another area of attack for this, and something for people to think about. We've shared some of those
Yes.
examples out there before. With the Boeing Chinook
Hmm.
fleet, we've shared that. We've shared some of the robot applications, and again, they're finding that they're about cutting the grease consumption in half. And we're talking about lithium greases in a lot of
Oh,
cases, and there's all
yeah.
that upward price pressure from lithium being utilized for batteries and things.
Yep.
We need to get ahead of it. We don't
Hmm.
need to go back to the supply chain disruptions that we saw during COVID, right?
No.
And some of those supply chain disruptions were made worse by
Hmm.
higher than necessary demand, right?
Yep.
So people are like scurrying trying to find pails of grease, and really
They
they
don't
wouldn't have
need.
had to use that much if they were
Yeah.
optimizing. So now's the time to look into that and see what we can do. I know the folks in ultrasound are doing a fantastic job
Yes.
with that, helping people keep from just greasing until it comes out
Hmm.
somewhere with some feedback from ultrasound. But also, there's other factors that we've talked about, right? The accumulation of wear, the particles and contaminants that are getting in there, and then the oxidation life of the grease, so that we can really see when is that optimal. So there's a lot of examples of that. I want to do one more thing here today,
Hmm.
which is to share a video, and
Right.
I'll just
Okay,
let
now
this
I'm
roll a
going to
minute.
show how to take a sample from a bearing surface just using the pickpocket device and then our grease thief filler. So I'm just going to use a little rod here to
So I
help
already
open
made a
the
mess
filler.
once. I figure why make a mess
Filler
again?
comes with
I'll
two
just
I
I'll share
parts.
agree.
the video
This
with you, right?
is the sample cup area.
But
This
some of the
is
things
the
I was showing
piston
you a little
area.
earlier,
And so we
and
use
then
Hmm.
both of
on
these
the table
parts
is the inner race of a
along with a
bearing that I've
straw
speared
that has
some
been
Right.
actual grease
reddened
samples that have
in
come in.
this
So we're
position. So you've got an
kind of
open
showing
end
how
of the
you take
piston,
an actual
and then if
grease
I push that
sample.
through the straw
Here I'm just using a little rod
and
to
put that flush,
adjust it,
that's
but
now the solid end
but
of
we'll
the
show
piston.
you
So
the
with the
actual
solid end of the piston
sampling of the grease here.
facing the cup, we just put that in there and it holds it in place. Now I'll put the piston down, use a spatula to take the grease from the bearing
Right.
surface and put it into the sample cup. So I've got some actual grease samples here that
Some
I've
red grease.
pre-distributed on the bearing
Yeah,
surface,
the red grease is the
different
good stuff.
degrees
Oh
of
yeah, yeah, totally.
consistency or firmness, because in an actual situation you're going to have solids and you might have the grease drying out due to temperature or being worked or what have you. So we have to be able to take greases of varying consistency and be able to get that transferred. So this is just really showing how that process works. So I'm going to try to get as
So I
much
used
off
a
of here as I
tiny little
can,
bearing here,
and
so I
hopefully
gotta
it's a slight
kind of have to go
process
around. The
to
nice
get
thing
the
about
part
this
sample
cup
out.
is you'll realize at what
That's
point you
the
have
bearing
enough
there.
to
Now sometimes
transfer it
it gets
over,
caught in the
right? Because
spatula,
you'll get
so you
a
can
feel
even use
for
the tip
that kind of
of the
cone
piston
shaped
to kind of
grease deposit that I
transfer the
talked
last
about,
bit. And the
and
idea
how
here
much
is
gives
that
us
it's
enough
a
for a
fairly
slight
efficient
excess.
transfer. More than 90% of the volume of the grease that you take, we want that to be able to end up in our sample. So now I take the piston, put it into the sample cup area, engage that, and then I'll hold this so that you can see it, but normally you
Good.
could just put it down on a surface. But I'm going to start pressing on that piston,
Ah.
and you can see the little black piston inside the straw moving forward, and we'll
Yep.
continue to transfer as much of that grease as we can, getting it close to full if possible.
The nice thing is if you hold
So
it on the
now at this
table or a
point,
flat surface or
move
even the
the
back
piston
of
to
your
the
hand,
far end
the piston will stop
and
at
move
that point,
this line
and
Ah,
then you'll feel
exposed
the back pressure and
and
you'll know
single
that
use.
you
We don't
filled,
have to
you
filled
have
the
transfer
entire
enough.
straw. Yeah.
materials from one sampling location to the other. And then I have this small vial. I put piston side down into the vial,
Good.
cap it. Now that's ready for analysis. So what you have is a completely full section that's going to go into your FurrowQ device, measure the ferrous content consistently. And by filling this straw and moving the piston to the far end, we would then consistently get the same amount into that straw. And so the parts per million values of the FurrowQ will accurately reflect the concentration in that sample. So just encourage you to look further into this and see this as a new method to be able to prepare samples for ferrous testing with the FurrowQ. Now, one nice added feature here is
I
that
do the transfer here now.
if we
Right.
decide this sample for whatever reason, it could be due to the color, because this is a very dark sample, or it could be the results of the FurrowQ that tell us the ferrous content. I can then take the samples that I want to test further and transfer them over.
Of course, I dropped it.
So take this, and let's say I've got a grease thief and I want to do a full test sleeve. I'll take that piston end at this end, put the open end into the grease thief, pull the piston back in the grease thief, and then use a rod to transfer
Right.
that over. So I'll just pull.
That's just pushing the piston in,
Yep.
transfers it all over.
Completely fill the grease thief.
Yeah.
So now at this point, move that piston. But I've really transferred that entire volume over to the grease thief. I'll just take my cap, put that on there, and send that to the lab for analysis.
That's it.
Yeah, and that's it.
No
And
contamination.
so what that does then is it just sets it's really simplifying the process, right? You know at every step what you're targeting. You know that in that you have to fill that cup of the GT filler, then it transfers over. By the way, I don't know if you could hear that, but I said that it transfers more than 90% of the sample. And this was one of the things that we ran into trouble with these syringes, is
Yes.
that we would have, we'd pull the plunger out and we'd be putting the grease we have in there. And for like the helicopter, some of the spline applications, we would go ahead and we get all the grease we possibly could. And we go like this. And then there's all this grease trapped in the tip of it,
Yes.
left behind. And it's like, boy, we work so hard to get a sample and we can't even get it
The full
to the
amount.
place to analyze it. But I think we got it up to about 93% volume
Wow.
transfer. So that the whole design of that GT filler is really optimized at making a sealed chamber and then getting as much of it into the grease thief or really the pickpocket tube as you can, so that your efforts aren't in vain. Sometimes
Yes.
we're working with machines that have an excess of grease, and sometimes we just
They don't. Yeah.
we don't. We like this. The targeted area is going to tell us what's going on. Is a very small volume, and that's that's why we targeted originally a gram of grease. We said that's a reasonable ask,
Yes.
and now we're working that into the design as we go forward. So, that's what I wanted to show today, and I think we can. If there's anybody on the podcast here who has some questions, we could probably take a few questions.
We can definitely take a few questions because I saw that Linda Perry, she's very big on sustainability, and she says, thank you for what you're doing and that you're thinking of everything, of course. And I know we have Greg Christensen joining us, and he says, it's amazing what, the thought process that actually goes into trying to find out, how do we do this? And I know, I think a lot of other people are joining online as well. But I don't have any questions yet, though. That's the only thing. No
Yeah.
questions yet.
Well, I think it's so new, that folks just have to get their hands on it and see how it works in an
Yes.
application, and certainly then we can have some one-on-one dialogue about why does it do this, or is this what you
Yeah.
expect, or whatever. And but it really is a fairly simple process. And
Mm-hmm.
from our very first designs, we were building kits to kind of go up to the top of a wind turbine tower, right?
Right.
Everything there you needed, because you don't want to make an
No.
extra climb when you're hundreds of feet in the air.
Well,
But
definitely not.
now it's like, well, let's keep making that. Let's keep that design simplicity,
Mm-hmm.
as much of this as we can going forward. And I think that's what we have. And then also being more open in terms of format
Yeah.
of how the grease is dealt with once you have that representative sample.
Mm-hmm.
So sometime here within the next few weeks or a month or so,
Yes.
we're going to hit the market with these things. And
Yes.
I think it's a great time for people to reach out to us and say, hey, I'd like to try some. Let's get
Mm-hmm.
me a starter kit so I can get my hands
Yes.
on them. I did my best to demonstrate it, but there's nothing better than having hands on
Virtual.
and,
Yeah.
yeah, try it yourself. And I'm excited to see the end use community come back and say, have you thought of this? Or could we
Mm-hmm.
modify it this way? We want to be flexible, and we want to
Yeah.
make it as versatile as possible, a solution with the input of the people who are the asset owners and will be,
Yeah. Because they are the ones using it at the end of the day. So
yeah, yeah,
they will find the challenges that we may not find. Because, it gets very creative out in the field there.
that's
Very
right.
creative.
Yep. Sometimes we see it on the lab side where it's like, wait a minute, where did all this come from? And
Yep.
you kind of wonder
Yep.
what the techniques were. But that's why I think it's our responsibility to continue to
Mm-hmm.
improve the methods, make it simpler, make it less expensive to get
Oh,
involved
it
and
is.
to get some answers, and also be environmentally responsible in the
Yes.
process as well with the single use plastics. So
Yeah.
I
I
think
think you've
we've
done
hit
a
this.
really good job with that part because, like, the amount of the reduction that you have shown definitely over the years from initial to right where we're at now, that's a huge reduction. So, thank you for
Yeah,
doing your part.
Yeah, sometimes that comes out of necessity, though, because during the
Oh,
COVID
yes.
shutdown, syringes were hard to get your hands on.
Yep.
And what we did find early on was that the inside diameter of the syringe tip potentially could affect the grease measurement,
Ah,
because what happens if you have a very small opening, it doesn't matter when you're delivering liquids, they'll just flow
mm-hmm.
through there. But if you have a very small opening, you're forcing that grease to shear down through that
Yeah.
opening. And we could see, so we had put a quality spec on the syringes that we were
Ah,
obtaining, to have a large enough. We had a minimum diameter, because it's smaller than that, it would be breaking up the structure of
right.
the grease, and we didn't want to affect the measurement. But that's a non-issue now with the GT filler,
Yeah.
because it's almost as large as the tube or the grease thief
Yep.
that it extrudes through. So again, you're always looking for these things, and for us to be coming up with sampling solutions and being an analyzing lab,
Yes.
we kind of check our own designs, right? And say, is this really
Definitely.
doing a good job? Is it changing the data? Is it easy to process? One thing people don't realize sometimes is that sampling doesn't happen one time.
Oh,
When
yeah.
you're sampling lubricants, you might have sampled it in the field from your machine, but then it gets into the lab and it's being sampled multiple
Mm-hmm.
times again to
Yep.
introduce different tests that are being done. And so that's all kind of incorporated into this design.
All right. Well, I don't think we have any other questions, and I know that you have a 1 o'clock.
Yeah,
So I guess we're gonna end off today, and I will send out the link, the official
okay.
link, to everybody for those who missed it and couldn't find us today. But thank you all so much for joining us, and thanks, Rich, for always, innovating and thinking ahead. Always thinking ahead.
Sure thing. Thanks for having the leadership here for us. And we'll look for some more ideas next month, and we'll
Oh
bring
yes,
this back again in September.
definitely for sure. Thank you all so much.
All right. Have a good day, everyone.
You too. Bye.